Hello everyone, welcome to today's webinar Wednesday. I'm going to give people a little bit of time to trickle in before we start. I apologize if I'm going to be coughing a little bit during this webinar. I fell sick somewhat recently and I'm still recovering, as you might be able to hear from my voice, so like that, I apologize. I will do my best if I can to try and mute myself where possible, but just so you know. And thank you. Thank you, Zabrana. I will do my absolute best too. Should be... I think this one's going to be a little bit of a shorter webinar today, but I hope you're looking forward to it all the same. And I guess, without much further ado, let us introduce today's webinar topic. We are taking a look at test coverage and examining what it is and what it isn't. As always, I'm your host. Well, not as always, but I'm your host for this webinar. My name is Benjamin Taylor, and of course I work with Go Bigger, and I'll have more to say about us at Go Bigger at the very end of this webinar. So, without much further ado, let us get into today's webinar. And of course, as always, we start with what we're actually covering in today's webinar. So I want to examine a couple of key things. First of all, I want to look at what test coverage actually is, so we are all on the same page. I then want to talk about what test coverage actually is not, because test coverage is one of those words that we throw around a fair bit, and it's important to understand what actually test coverage isn't, so we have a clear idea and knowledge of how we should use it moving forward. And finally, I want to look at where we should focus to look at for test coverage. So test coverage is an interesting thing in that actually how we focus on test coverage and how we look at it sort of depends on what level of testing we're looking at, but I'll get more into that later. For now though, let's look at what test coverage is. Which, if we follow the ISTQB, they define test coverage as being the degree to which specified coverage items are exercised by a test suite expressed as a percentage. And I think that's a pretty good definition, because when we're talking about test coverage, we can talk about different kind of coverage items, as ISTQB says. Coverage items can be the sort of main idea of what we think of with test coverage, which could be a percentage of code run in the test, so the number of lines of code, how many of those get run in a test, or multiple tests in a suite, for example. Or instead, we can take a look and see the percentage of requirements that have been run in the tests. Oftentimes in projects, we'll have different acceptance criteria or different requirements that each feature or unit or component may have to have. And so we can actually look at how many of those requirements have been met in our test cases overall. This one's a bit more nebulous to discuss. So let's first of all talk about code coverage first and get a better idea of what code coverage can mean. Because when we talk about code coverage, we can sort of break down our code coverage into a couple key crucial sort of components or methods. First of all, we can look at code coverage to be statement coverage. This is the most basic, bulk standard type of coverage we can have, as we're just looking at sort of the individual lines of code. How many lines of code do we have in our overall project? How many lines of code does our tests actually run? If we can get 100% code coverage, then excellent. It means we've run 100% of the lines of code in our program. Doesn't mean that we've run all the lines of code well, and especially if there are errors, for example, doesn't mean that we've potentially triggered those errors, but it does mean we've hit 100% coverage of lines of code. We can also move on to taking a look at branch coverage. Branch coverage is a bit more challenging to, let's say, ascertain and to identify, but branch coverage is the number of branching statements that we've had and we've encountered in our code. This works best if branching coverage is probably easier to understand on simpler to medium-sized applications, where we have sort of a central loop or process that occurs and then everything branches out from that. And then branches, of course, can not only be in if statements, they can be in different kinds of loops, it can be in error handling. So branch coverage sort of details where our code goes. And if we can say we have 100% branch coverage, then it means we've accessed every single possible outcome from our loops, from our decisions, from everything. Sorry. Branch coverage does supersede statement coverage. So 100% branch coverage doesn't mean 100% statement coverage. Statement coverage, 100% does not mean branch coverage, however. That is definitely important to know and understand. Reason being, say, to take a simple if statement, for example, an if statement can have an else, or it can have just no else at all. It could just be a simple if and then continues on. Statement coverage, if it goes into the if, would say, yes, I cleared all statements in this section. Branch coverage would say, actually, I haven't cleared all branches, because whilst the code has all executed, we haven't seen what happens if we didn't enter the if. So, important to keep that in mind. That's sort of just good generally to know. Then we have requirements coverage. Requirements coverage is a bit more complex because it deals with counting the actual individual requirements that we have in our project. When we talk about requirements coverage, and when we get a list of all requirements that we have and we can test against, ideally, by standard, we weigh each of these requirements equally. This means that a very sort of high feature, very important feature, could be worth multiple points compared to a smaller feature, or maybe they could be the same amount of points. It's important, and it's up to you, tester, or maybe your business analysts, to really understand and say how much these requirements are worth. Of course, we should always be testing 100% of our requirements, but strictly speaking, we should always aim for at least a very high percentage of requirements. Sorry. Looking at my other monitor I have. My bad. But requirements coverage doesn't imply statement coverage or branch coverage, because it can be very easy to get 100% requirements coverage and not touch some aspects of the code. So that leads us to sort of our big next question of, how do we define what is tested? Because anyone can make a test that goes through the code, but that's not necessarily a good test. Because when we look at what test coverage isn't, test coverage doesn't indicate how well something has been tested. Test coverage only looks at it and says, well, yes, it has been tested. And that really should ring some alarm bells and start some processes going off in your head that says, can we trust what is actually being tested here? I'd say that test coverage should never truly be the sole confidence factor in reporting in our projects. If you want to know more about reporting, then you can check out one of my previous webinars in which I looked at different testing metrics we can use when talking about testing. But speaking about otherwise saying, and one of the summaries from that webinar, test coverage is good, but it definitely shouldn't be the sole confidence factor, and it shouldn't be the be-all, end-all of how we talk about our testing metrics. And why is that? Well, because testing coverage doesn't tell us everything. Testing coverage doesn't tell us the rigorousness of our tests. So how rigorous were our tests? How in-depth did they go? Did they just call this endpoint and then see, yep, the endpoint responded 200, it's all good? Or did we actually look at the fields? Did we check if fields existed? Did we check what the value of those fields are? Especially in API testing, which I'm doing right now, it's really important to actually not only check that the fields exist, but we have the values that we expect. Then we look at test data. What kind of test data was used? We can use any kind of test data to get test coverage, but we need to make sure we have good test data for what we need. Maybe we need certain test data that goes down certain pathways. If so, we can get a really high test coverage by not using good test data, but that doesn't mean a lot. So, really strong test data definitely helps us out and can increase the rigorousness and the overall just betterness of our tests. And then, of course, what expected outcomes do we have? What are we looking for when we're testing? Are we testing to make sure that a field exists? Sure, maybe that's okay. But what if we want to make sure that actually there is something there? And not just something, we want an exact thing. It should be what we should get from this endpoint or this field or this value is this. And that's a really crucial aspect of testing that test coverage doesn't give us. So we need to keep that in mind when we're talking about it generally. And lastly, I'd say sort of what viable measures we have to reach when we're talking about coverage, because 100% coverage isn't always possible, which is the sad truth. We can deny it, we can fight against it, we can spend a lot of time to get 100% test coverage, and we probably should in multiple ways, but what if we can't reach it? Do we say that 90% test coverage is okay? Do we say that 8% coverage is okay? How do we gauge what is good and what is bad? Depends on the system, depends on us, depends on the importance of the project we're working on. But test coverage is a difficult thing to sort of measure and get right in that aspect. So that's why I say, if we're looking at test coverage, well, then we need proper tests. Because if we don't have proper tests when we're talking about test coverage, then they're not useful. They're just green tick marks, which, sure, look nice, give you that false sense of confidence, but we need to make sure that they're actually really doing something. So what can we do? Well, I'd say one of the first things, and one of the most basic things we can do, is just make sure that our tests make sense from a business perspective. Make sure that the tests we write, actually check out and make logical sense from the business or from the user endpoints. The test may say that it does something and it checks something, but actually when you dig into the test, you may find that it doesn't actually do that, or it has this sort of weird hacky solution, and it's like, how did that quite get there and get through sort of other checks? And that's something you have to keep in mind and keep an eye out on, because I have to make sure tests actually do what they say. And making sure that tests, well, not only make sense from business perspective, make sure tests do what they say they do. If a test is saying that it should go and check these 5 fields, then it should probably go and check those 5 fields. Not just maybe field 1 and field 5 and say, field 1 and field 5 are correct, so we can assume everything else is good too. No, let's actually check all proper areas and make sure that our test is really correct and sort of really strong too. And I think a great way to sort of make sure these tests are useful and make sure they're actually quite viable is following an idea from behavior-driven development. We write breaking tests first. We write our tests, make sure they break, make sure we don't get the response we want, and then we fix our tests. This can either be adding more information, fixing up some development issues, or otherwise. So we want our tests to break, because after they break, we can see how they broke, and then we can fix them and make sure that they are best as possible. They make sense from a business perspective, and they are doing exactly what they say they are. So then we get to what we should call test coverage and what it actually should be. So test coverage itself should be a way to ensure that all aspects of code are reachable. We're looking at statement coverage and branch coverage. You can't get 100% branch or statement coverage without making sure that your code is reachable. Not only do I mean functions that aren't called, and we have to make sure we don't have any of those, but also different conditions on if statements or loops or switch statements. We have to make sure that it can actually reach those outputs. If we can't, then we need to understand why we can't. Is it a test data issue that we could potentially fix? Are we reliant on a third-party service that maybe needs to encounter difficulties to reach this? How do we test those specific aspects ourselves? And that can be really quite challenging. But that is a good sort of goal for test coverage in general. Test coverage should also, of course, ensure that all requirements have been addressed. Look at the business requirements for the component or the system that we're making and say, yes, all of these have actually been met in our tests. We are testing for each one of them, and that means, of course, that they are implemented in the software itself. If our requirements haven't been tested, then maybe they don't exist in the software, and that's something we should really look out for. And testing coverage should also be, or could also be, sort of low-level approach for verification and validation, of which I'll sort of get further into. But what I mean by this is that we can say very high test coverage normally means that our system should, as long as we're following these sort of other aspects and making sure that our code is reachable and requirements have been addressed, then generally enough we could probably say we've verified and validated our kinds of tests that we do on a low level that we'll get into now. Because I want to say that test coverage can actually be sort of broken down into the different levels of testing. And let's take a look at those sort of levels and sort of see how we can think about test coverage in that way. First up, we have the component and unit testing. One moment. Okay. So when we talk about component and unit testing, I think this is the perfect stage in the testing pyramid that we can go for high code coverage. Of course, we are testing the individual component that's been made. It's just one small aspect, and so it's really good if we can get full coverage in that area. And that's where I think we can get really high code coverage, so great statement or branch coverage. But if we're only looking at a specific component, we may find that we actually have pretty low requirements coverage. It may be quite difficult to get different requirements out of this from just a component level. For example, let's think of a calculator program, and let's think of the different arithmetic expressions, addition, subtraction, multiplication, division, as their own sort of components or units. And some of our requirements for the calculator may be that a user could use different mathematical expressions in one statement, and the calculator would provide the correct response. In this case, it can be really easy, for example, if we're looking at just the addition component, to test addition out, see what happens if we add negative numbers together, add fractions, add decimals. What happens then? Our calculator can test that. But just having addition might prove quite complicated for our overall requirement of having multiple arithmetic expressions in one line. So low requirements coverage, but pretty good and really good code coverage. And from that point, from our component and unit testing, every subsequent stage can build up in confidence from the previous. So this means that once we get to component integration testing, overall component integration testing, just that specific stage, may have sort of medium level of code coverage. So It'll cover a wide variety of things, probably getting to like 90%, 85%. But it won't cover everything. And that's okay, because we can trust, and we should trust, as long as the tests have been good, that the unit and component tests were equally good. But being in the component integration stage means that we can actually probably get to a lot of requirements as well. This means that for our calculator program, this is when we can combine our different arithmetic expressions together. So we can use addition and multiplication or division as well, all in one line. And that's where we can get all of our, that's where we can get a lot of our requirement coverage sort of set. So we may not get in as deep with the code itself, but we understand what's really going on, and we're building up there. And of course, that building up is getting us to the final point of when we purely sort of examine requirements, otherwise known as system testing. So system testing, we're looking at, unfortunately, I'd say a low potentially low code coverage, because not necessarily we're going to look at all the code, and I say potential to mean we may only look at like 70% of the actual code in our system tests. But that's okay, once again, because remember, we're still getting really high code coverage in our unit and component tests, and still high medium coverage in our component integration tests. So we can be reassured that while we do have low test code coverage, we actually still have quite good coverage overall. And of course, our system tests can give us some really high requirements coverage here. Our calculator program not only does it do several arithmetic expressions, this is probably also when we look at graphical user interfaces and how people can interact and that kind of thing as well. So that's sort of how I want to break down test coverage and how I think it sort of makes sense to. I think it's beneficial to look at it that way of not just, yep, 100% coverage, it's good, ship it. No, it's like, actually, bring it back. Look at these different layers, look at how they interact, and see if that all makes sense and if it does actually sort of flow and work as we intend. So where should we look at for test coverage? And I'd say the layer that we're testing directly impacts how we should examine test coverage overall. Basically, as I was saying, because if we want to look at, for example, our system tests, and we want 100% code coverage, then, well, you're going to be spending a lot of time running your system tests, because you're looking for, well, could be some really specific and exact situations in which something breaks. How do you do that? How do you fix that? Well, how do you enable those environments in the first place? That can be quite a challenge, actually, just to be like, we may have these safeguards in place. How do we trigger them on purpose? That can be really difficult to do. But if we want to look at, full requirement coverage in our unit tests, then you're probably getting your unit tests to be massively bloated and sort of missing a point of what a unit test may be. Maybe you are mocking every other call in a unit test, or maybe like 80% of a call in a unit test, because it's supposed to be actually talking to all these other components. You haven't made a unit test at that point, you've made a system test for one specific unit or component. And it just doesn't make sense to look at it like this. So let's think about what layer we're working on with and how we should actually test those. To which I have a little scenario we can work through that I think is going to be sort of beneficial. So in our scenario, we are testing a brand new e-commerce commerce service. And we can generally say that the service is going to contain three main components that need to interact and work together. Those are user management, the product displays, and payment processing. And of course, this means that the important question then sorry, distracted by a second monitor. The important question then is sort of what standards of test coverage do you use throughout the development cycle? It's a big question, and it's a really difficult one too. If we just talk about requirements, for instance, and let's say user management, we can say that users should be able to log in, have their address saved, maybe even a payment method saved, as well as having a shopping cart. Those are sort of a couple key factors that should work together. We then have our product displays, so the actual, commerce part of our e-commerce service. So how are our products displayed on websites? How can users filter to find specific products? How can they work those out? And finally, payment processing, of which payment processing itself is just a sort of big component, but it may be how do you talk to different banks or credit card companies? Do you offer PayPal or Google Pay? These kinds of things. And you can have sort of requirements and coverage options for each of these components at a small level, but you should also, of course, have requirements at an overall larger level that includes one or two or even all three of these larger components together. And so, test coverage, a basic number that says, oh yeah, we test 100% of all of this, that doesn't mean anything. What does that actually say? What story do we tell? And I think that's sort of a real challenge, and there is no right answer for how we look at this scenario. No one right answer, should I say, because there are right answers, as there are wrong answers. But it's all a matter of what's expected, what should we aim for, and of course how we make our tests. And so, to bring us to a close of today's webinar, of course, obvious, every project is different. And I'd say that test coverage can be quite a useful metric overall. But, and a very important but, we need to properly test what we're developing, and of course test it in a way that makes sense. If we are looking at an individualized component, then sure, let's go test coverage, let's go lines of code. But if we're looking at an overall system, then maybe let's drop lines of code for now, and instead look at requirements overall, see that it meets all of the features and specifications that have been requested. Doesn't make sense to do it the other way around. And that may be obvious, but it's still really important to sort of understand and visualize. And of course, when we talk about tests, we want to have tests with stories. Importantly, don't have tests without a story. All of our tests should have a specific goal in mind. Even if that goal, for example, let's go back to our calculator, even if that goal is just what happens if we add two negative numbers together. What happens if we add two negative numbers together? Do the negative numbers grow into a larger negative number? Do they equal out? It's important to ask that story and to really go, what are we testing at here? All of our tests should have a purpose. Cutting one test should mean that you are lacking some crucial bit of information about your product. And when you can cut no tests, then you know you have a fantastic testing suite. And I think that brings us to the end of today's webinar. So if you have any questions, feel free to put them in the chat and I'll get to them. But as I wait for questions to come in, let me talk to you about Go Bigger. Go Bigger is an IT consulting company specializing in testing and testing automation. And of course, since you're already here in the chat, you're probably... Oh, I see a good question. Okay. You're probably already following us on LinkedIn, but if you aren't, then why not go ahead and give us a follow? You can keep up to date with everything that we're doing at Go Bigger, plus keep up to date with our new upcoming webinars. And if you want to know more about us and check out what we do, then why not go ahead and check out our shop to see our currently available courses and other offerings. Right now we have courses available for Robot Framework, as well as the Robot Framework Certified Professional certification. you're interested in getting certified in a really great test automation tool, then go ahead, check out our Robot Framework certification, and would be happy to work with you and guide you through that process. Plus, if you want to stay fully up to date with us at everything Go Bigger, then why not subscribe to our monthly newsletter at Grow Bigger. We email you once a month to keep up to date with everything that we're doing, as well as what's happening in the testing world. Plus, you can always subscribe if you don't want to keep updated. No bad feelings, we won't take it to heart, but it's really easy to subscribe, so why not go ahead and do that. And I see a question in the chat. So we have a function, add a b returns a plus b, test add bar results equals add 1 to assert true. Zabrana, well, yes, that is indeed 100% test coverage. There are no edge cases missed, but I would point you back to looking at this, specifically the expected outcomes. Because yes, of course, we can just assert true, but that's not a great outcome we're looking for. And that's a really important part of testing. So it's not only that, yes, we test that 1 and 2 can work, sure. But it's testing that 1 and 2 does indeed make 3. If 1 and 2 makes 4, then we may have a logical issue, probably raise a bug ticket to your developer. Maybe also send them back to first grade. I think that may be beneficial for them. But I think that's everything I have for now, so if there are any other questions, feel free to put them in the chat, but otherwise, I hope you enjoyed today's webinar Wednesday, in which we looked at test coverage, and hope you'll look forward to about 2 weeks' time with our brand new webinar. Stay tuned to our LinkedIn for more information. Until then, have a wonderful rest of your week. This has been Benjamin Taylor from Go Bigger, and we'll see you next time. Goodbye. And I see the chat message. Successful test is an awesome test. Successful test is a nice test. We don't always want to be nice. I think I'll leave us with that. Alright. Take care, everyone. Have a great week.